Okay, so this is a graphic organizer to help you remember the difference between the four different triangle centers that we're going to talk about. You may be surprised to know, I was, that so far in October 2024, there are more than 65,000 identified triangle centers, and they all use different lines and different ways to find the center, but 65,000, that's a lot. Okay, so let's do the four that we care about for now, and we remember them by saying crunchy peanut butter is always better on a cold morning. You go, well, that's silly, but it should help you remember that crunchy peanut butter stands for the circumcenter, and I didn't really make this as big as I wanted to. The circumcenter you find by drawing the perpendicular bisector. And we've talked about the perpendicular bisector a couple times before. So the things to notice on your picture are perpendicular bisectors have right angles and perpendicular bisect your line, right? So that these guys are equal. I don't think I have enough colors to do what I just started doing. These guys are equal, and these guys are equal. So a perpendicular bisector starts in the middle and goes straight across at a 90-degree angle. And the place where they cross is the circumcenter. All right, circumcenter, things you might want to remember, that the sides are equal parts. They're cut into equal parts, cut in half, and we have right angles. Okay, so if you drew a circle around the triangle like you see in the picture, the circumcenter is the center of the circle. Around the outside. That's just a fun fact. Okay, so when you draw the circle around the outside, the center is the circumcenter, which is also where the perpendicular bisectors cross. Okay, the next one is always better, is for the incenter. And the incenter is found by drawing angle bisectors. All right, and so angle bisectors cut the angle in half. So before we cut the sides in half, this one is going to cut the angles in half. So that means this angle and this angle are equal. I guess I'll use blue. This angle and this angle are equal because they got cut. They got bisected, and I guess I can use green. This angle and this angle are equal. So all the angles are equal, and the place where they cross in the middle is called the incenter. Okay, so the thing to remember is equal angles because they were cut in half. Okay, and if you drew a circle inside, it would be the center of that circle. Center, this one doesn't have a circle, so you'll have to kind of imagine. Center of circle inside, inscribed was the word we used, the triangle. That would also be the incenter. Inside, incenter. Okay. On A is totally boring words to remember, but if you remember on a cold morning, you'll get it. O is for the orthocenter. And for the orthocenter, we draw the altitudes. So when we talked about the altitudes on our note, the altitudes are perpendicular lines from the vertex. So things to notice. These are perpendicular, right? But they are not in the middle. They are not bisectors, okay? Let's see. All right, so the lines are perpendicular. Oops, not what I wanted. Perpendicular from each corner or the vertex or the vertices. So you started at corner A, angle A, you drew a line straight down to make a perpendicular line with BC. Then you started at C, drew a perpendicular line with AB. Then you started at B, drew a perpendicular line for AC. The thing to remember about orthocenters is they can be on the inside or the outside. The triangle. Okay, so sometimes your orthocenter would be outside the triangle. Okay, and then cold morning. It's going to be our last one. This is the centroid. And you find the centroid by drawing the medians. And we talked about the medians. So the medians are, I'm not going to use yellow because I use that for the other ones. The medians are the middle, which so it cuts these in half. I'm trying to match my colors that I used a minute ago. Right, so those are equal. Then I use some weird orange color for this one. No, it's not really the same. Okay, anyway, so there are no perpendicular bisectors, but the lines start in the middle of the sides. So if you started a line in the middle of the side and drew it across to the angle, then where you were in the middle would be the centroid. Okay, so they have equal sides are, oops, let's do that in red. Sides are cut in half, bisected, but I don't care about the angles, what kind of angles they make. The sides are cut in half, which means they're equal parts. Okay, so hopefully that helps you remember, maybe or maybe not. The cool thing about the centroid is that it's called the center of mass. If you cut out a triangle and you found the centroid, you could put the triangle on your pencil and it should balance because that's the center of the mass of the triangle. And it's 2D, so it doesn't have a big mass. But if you found the center of mass, you should be able to balance it on your pencil because that's the center. That's that kind of center. So hopefully you'll keep this with you